Now today we'll be looking at converting from a decimal numeral, that's base 10, to other bases. Now these are the key things that you need to note when you are converting from a decimal numeral to other bases. Now the first thing you need to consider is that you are going to do successive division. That's, you are going to divide repeatedly until there is nothing left to divide. In view of that, to solve cases like that, you need to construct three columns. This is a sample of the three columns. See column 1, column 2, and column 3. Now the column 1 will contain the base. Column 1 contains the base. Column 2 contains the decimal numeral. And the column 3 will contain the remainder after each division. Now someone may ask, what or how would your final answer look like? The final answer is written by writing each of the remainders you are going to get here from the bottom to the top, and finally attaching the base to it. So we are going to take one example to support this argument we are discussing here. We'll pick one example to support it. Now let's look at this problem. We are going to convert 27 base 10 to base 2. 27 base 10 to base 2. So what we are going to do is that, per what we have here, we need a column for base, a column for the decimal numeral, and a column for the remainder. So we have the base is 2, the decimal numeral is 27, and a column for the remainder. Very good. Now the question is, how many times will 2 go into 27? So 27 divided by 2. 2 goes into 27, we have 13, remainder 1. So write 13 here, remainder 1. Now how many times will 2 go into 13? So we have 13 on 2, we have 6, remainder 1. So we have 6 here, remainder 1. 2 into 6, 2 into 6, we have 6 here and 2. We have 3, remainder 0. 2 goes into 6, 3, remainder 0. Now 2 into 3, we have 1, remainder 1. That's 1, remainder 1. And again, 2 cannot go into 1. This is because 1 is less than 2. So since 2 cannot go into 1, write 0 here, and we bring this. So you are going to be left with 1. This is the remainder left. Remainder 1. So what we have here is that now we are done with. So the thing is, we are going to divide repeatedly until there's nothing left to divide. So you can see that there's nothing left to divide again. So if there's nothing left to divide, then it means we are done. As soon as you arrive at 0, then it means you are done. So we are going to write our answer. We're going to build our answer right from the bottom to the top. So 27 base 10 becomes 1 1 1 1 0 1 1 0 1 1 base 2, and this is your final answer. Now the next example is, you are going to convert 304 to base 5. 304 to base 5. 304 is in base 10, so base 10 you can also write it this way without writing the 10 there, because in number basis without any base, we assume that the number is in base 10. So let's go. So we need a base here, and we need the section for the decimal numeral. I need a section for the remainder. So first of all, 5 into 304, we have 60. Go 5 times 60 is 300, remainder 4. 5 into 60, we have 12. Go 5 times 12 is 60, remainder 0. 5 into 12, we have 2, remainder 2. And 5 into 2, 2 is less than 5, so 5 can't go into 2, so write 0 here and bring this remainder 2. So we are going to build the answer from the bottom to the top. So therefore 304 is equal to 2204 base 5. This is your final answer. Now the last example is you are going to convert 453 base 10 to base 8. So we have the column for the base, the column for the decimal numeral, and the column for the remainder. So with this, so we go again. 8 into 453, we have 453 divided by 8. So 8 into 453, we have 56. 56 remainder 5. So we have 56 here, remainder 5. And you go again, 8 into 56, that's 7. 7 times 8 is 56, remainder 0. 8 is greater than 7, so 8 can't go into 7, so we introduce our 0, then the remainder 7 here is brought down here. We are going to build an answer from the bottom to the top. So therefore 453 base 10 is equal to 705 base 8.